Hello everyone, in this video we are going to talk about modularity in dbt. We are going to discuss why it matters for your data transformation workflows. First, let's talk about what happens when you don't use modularity in dbt projects. When all transformations are combined into one large SQL query, you will end up with several problems. Your data cleaning, calculations, and business logics are all tangled together. The code becomes long, complex, and hard to read, and you cannot debug or test individual parts easily. There is no code reuse, so you have to rewrite the logic multiple times. And the big risk is that everything breaks even when you make small changes. So, what is the solution? The solution is modularity in dbt. Modularity is a best practice that will transform how you build your data pipeline. So what makes modularity more powerful? First, you break your complex SQL into simple reusable pieces instead of massive queries. You create clean manageable chunks. Second, it ensures modular through scalable data pipeline through clean structure and logic separation. Everything has its place. Third, every model handles one specific transformation. This promotes clarity and reusability. Write once and use everywhere. And finally, it simplifies debugging and impact analysis with clean model relationships. When something breaks, you know exactly where to look. The bottom line is that dbt modularity isn't just cleaner code, it is about building data pipeline that scale, easy to maintain, and actually make sense for your entire team. Let's take a real world scenario. We are analyzing student performance here. We have a raw grade table. From this table, we are taking the count of number of exams taken by each student. Then we are calculating the average score. Next, we are finding the highest score. If the average score is greater than 85, we are giving honor roll status. Else, we are marking as regular. Finally, we are grouping based on the student ID. But here is the problem. Everything is jammed into one query. The aggregation, the calculation, and the business logic. All mixed together. And we cannot reuse parts of it. This is exactly why we need modularity. Let's see how dbt fixes this issue. Here is the modularity in action. Instead of one massive query, we are creating a staging model called stage grade that performs just one job, cleaning the raw data. It selects the essential fields, filters out null, and that's it. On the right, we have documented everything in the schema file so everyone can understand what each column means. This clean foundation can become reusable for many downstream analytics. Simple, focused, and maintainable. Now we are in layer 2, our intermediate layer. This model is called int underscore student underscore metrics that calculates metrics. It references our staging model that we created earlier and computes total exams, average score, highest score, and lowest score. No business rules, just pure calculations. The ref function is the key here. It tells dbt to run the staging first, and any model that needs these metrics can reuse it. This is another modularity in action. And finally, we have layer 3, our Mart layer called student performance. This is the business facing table materialized for reporting. It references our intermediate metrics model and adds the business logic. We have a case statement to determine the honor roll status based on 85 points threshold. We are also rounding the average score and ordering by performance. Notice how clean this is. Each layer has clean purpose, staging cleans, intermediate calculates, and Mart applies business logics. That is the modularity dbt architecture at its best. Let's see the dbt modularity in action. For this demo, I have created a database in Snowflake. My database name is QuickMart Demo, and I have created a schema raw. Inside the raw schema, I have created a table raw grades with 5 columns: student ID, exam ID, subject, score, and exam date. And I have inserted some records into my table. Here is my insert statements. Let me select my raw grades table. Here is the data. Now look at this query. This is the non-modularity approach. Everything is jammed into one CTE. From the raw grades table, I am counting the exams, the average score, high score, and applying the honor rolls business logic with case statement. And I am grouping based on student ID and ordering by average score. Here is my CTE. Let me run this. Here is the complete query result. For each students, I have the total exams, their average score, high score, and their status. All in one place. This approach works, but the problem is we cannot reuse parts of the query. It is hard to debug. You can see the result of this data. Now let me show you how dbt transforms this into clean modular pipeline. Let me go to Visual Studio Code. Let me show the difference in Visual Studio Code. First, here is the non-modular approach. I have created a fact table, fact grades, with a CTE query that I showed in the Snowflake. I am creating this as a table. Here we have the data selection, the calculations, and the business logics all tangled together. Now let me show you the modular approach. I have created 3 layers: staging, intermediate, and Marts. And I have created 3 different models. The model which I created in the first layer is stage underscore grades. I am using the source as raw schema. From that raw schema, I am using the table raw grades, and I am selecting only the required columns and eliminating the records without score. Here I am creating it as a view. In this step, I am doing only the cleaning operations. Next is the intermediate layer. In this layer, I am creating a view and I am doing calculations. Using ref function, I am referring the stage grades model. Next is the third layer, which is Mart. I have a model student performance. Here I have created a table and I am referencing from intermediate student metrics, and I am doing only the business logics, which is calculating the honor rolls, and I am also rounding the score to 2 decimal places. This is specifically for applying the business logic. In this modularity approach, each layer has one job, everything is reusable, and debugging is simple. Now let me run the dbt run command. We see that the fact grades table got created. Next, we have stage grades view got created. Next, we have intermediate student metrics view got created. As a last step, student performance table got created. Let me show the result in Snowflake. Here is the fact table. And we have the stage view got created. Next, we have intermediate view got created. And finally, we have student performance table got created. We see that everything is organized. Instead of one monopoly query that is impossible to maintain, we have created cleaner 3-layer architecture, staging for cleaning, intermediate for calculations, and metric for business logics. This is how you create data pipeline for your business. Start implementing modularity in your dbt projects and you will never get back to messy tangled query. I hope you like this video and I'm sure that you learned something new today. If you do like this video, please consider to subscribe and I'll see you in yet another interesting video. Thank you.